Enterprise networks are huge, particularly since customers and our staff are accessing those networks across the internet. For that huge complexity, you need AI. You need AI managing, operating, giving some oversight on your entire network. Join me on the Tech Field Day podcast as we dig into the need for AI operations in enterprise network. Welcome to the Tech Field Day podcast, where we bring together a group of IT experts to discuss a single idea around key concepts in the industry. This podcast features a variety of perspectives from members of the Tech Field Day delegate community and also from the companies that support us by presenting at Tech Field Day events. The podcast is often recorded in association with one of those events, and Tech Field Day is part of the Futurum Group. This podcast is also published on our sister company's website, techstrong.tv. On this spotlight episode presented by Juniper Networks, we're discussing the premise that enterprise networking needs AI operations. But before this discussion, let's meet who's on the panel today.
Hi, Alastair. I'm Jack Poller, Principal Analyst with Paradigm Technica. I focus on AI and cybersecurity.
Yeah, and thank you for having me, Alastair. Bob Friday, and I'm Chief AI Officer at Juniper Networks, or HPE now.
Hey guys, I'm Ben Baker, Data Center Marketing, HPE Juniper. I've been with Juniper for over 13 years now. In the data center world, little over 4, and I think data center is the hottest area in all of tech, so it's a great place to be, and glad to be here.
And of course, I'm Alastair Cooke. I'm an event lead at Tech Field Day. And well, congratulations first off that finally the DOJ has gotten out of the way and you've been able to close that acquisition by HPE. I think the combination together is going to be absolutely awesome. And I think one of the overriding themes we've seen throughout that data center management and network management is that the massive amount of complexity that's out there means that it's no longer tenable to manage everything through spreadsheets and WinDiff looking at the configs on switches. Hopefully we're a very long way away from my horrifying experience of network management back in the 1990s. But we really do need things that are more reactive and responsive. Policy-based management is awesome, but we really want to be seeing some more insight into changes and variations of what's going on in our environment. And that does tend to lead us to AI for all of the things. Bob, you're deep in the AI from the Juniper side. What are the big challenges people are seeing, and why is AI helping them, or how is AI helping them?
Yeah, Alastair, for me personally, I used to be the CTO over at Cisco, and I was actually trying to sell a big, large retailer this consumer mobile experience thing for their network. And they basically told me, hey, Bob, we're not going to put anything critical on this network, until you can promise me that your controller stop crashing. I had to make sure that we're going to deliver code more than once or twice a year. But more importantly, they said they had to make sure that that client to cloud experience was going to be good. That was the big thing. And that's when I kind of realized there was a fundamental paradigm shift from, hey, in addition to just, making sure switches, APs, and all that stuff is up and running in green, you really had to make sure that user experience was going to be good. And that was kind of the beginnings of realizing that cloud AIOps was going to be an architectural change in the enterprise. And so that was one reason why I left Cisco to start Mist. Was I knew there was going to be this real-time problem of how do you actually maintain that user experience on a very complicated network.
You brought up the 90s, Bob brought up, going back a little bit. And I think that's one of the keys to think about is talking about delivering the user experience. We, as IT professionals, as network professionals, we get very bogged down in the details, the technical details. And for some people, that can be a lot of fun. For other people, it's just the nature of the beast. What's ultimately most important is making the network invisible so that we just have the communication we need between the entities in our environment, whether that's people or AI systems or data processing systems. And if we can use AI to do that and get people out of the way, I think that's the big win.
Yeah, I completely agree. I mean, so many technology discussions start in the wrong place. It starts with the technology, and that's not the right place. We've all heard these edicts from above. Use AI, right? How are you using AI? Maybe you're hearing it from your networking vendors. You need to use AI in network operations, but it's a pretty aimless starting point. And agree with with Jack here and Bob. The starting question should be, what are your goals and what are the problems to be solved? And then you have to ask yourself, can we use AI and machine learning to help you solve those problems? And I think we're all aligned with the goal. It's to optimize the user experience, whether that's the network operator or that end user who's relying on that infrastructure for the applications that they use every day.
Yeah, what I usually tell people is that AI is really just the next step in the evolution of automation. The only difference here is we're starting to automate things that typically would take a cognitive human to do, right? I don't know. Have any of you guys tried this new Waymo Uber self-driving experience yet? You think about, AI, when you get into that self-driving Uber, it's something slightly different. Now, what I typically, ask people is like, do you consider that self-driving car automation, or is that an example of great AI?
Yeah, my answer would be that there's no either. It's a both. That the good solution has a foundation of some automation underneath it, and as you need more than simple automation, you start doing some of the ML kind of functionality of looking for trends and looking for, over time, what should I be expecting, what should I be looking ahead to. And then you move a little deeper beyond that to what are the unobservable pieces. And that's where the large language model stuff starts to come in, because it's seeing patterns that are beyond the capability of a human to comprehend, and still trying to take action in a way that is more human-like. There's a bit of a dichotomy there.
Yeah. And I would say also the interesting things, right? When people say AI now, they think Gen AI, right? Large language models, but there's actually two components to it, right? There's kind of the classic training models to do something. And that's what we have in our cars, right? A lot of vision stuff. In networking space, it's about training models to predict user experience. And then I think agentic AI is kind of a new non-deterministic, nonlinear programming language, that is going to help us really automate things in networking.
Yeah, well, I look at it and I think the last time I was hands-on with network equipment, I was at a startup with 50 to 60 people, and we had a single Cisco chassis switch with 648 port line cards. Now that's a complicated but not complicated environment. It's complicated when you're one person who doesn't know what they're doing working on it. It's uncomplicated in comparison to today's networks, which have many, many, hundreds of devices and thousands to hundreds of thousands of connections. And we get to a point where, just as with the self-driving car, the scale is beyond what a human can hold in their head and think about at one time. Right. And I think that's why, for me, that's why AI is so important, is because I just can't comprehend where all the different pieces go. We just can't keep it in our head. So how do you manage that if you can't do that?
And that's what I tell the average IT person, if the signal's big enough, they don't need AI, right? If it's obvious the DHCP server's down, I'm not sure they need AI to tell them that, the whole building's down. But, there's a great example. We had a customer in India. They're having all types of Zoom problems, right? People were coming in, they're getting all these Zoom complaints, everything. We were finally able to build them a model that could actually predict Zoom experience. And they were able to use some fancy math like Shapley to actually figure out that what was happening, they had a misconfigured VPN router that was routing traffic from India to Australia, right? That's kind of the needle in the haystack problem where I say the fancy math helps, right? Every now and then that fancy math does help you find those needle in the haystack where you have multiple things going in a complicated network now, trying to figure out what piece of the network is affecting user experience.
And there's some real challenges with that end user client connecting across the internet, where there's so much of it that you don't control, that you can only observe. So this is why I think, Bob, you've spent so much time on the client to cloud, because you get massive numbers of clients connecting through various layers that are shared, not shared. Many of the layers, like the router in India, is not being shared by people who are in Singapore, but other elements might be shared in their access across. And that complexity of having so many different endpoints and so many different paths back into the server is one of the elements that gets to be really challenging to manage. And those sort of, the subset is experiencing a problem, but I don't know what the pattern is that's causing this subset to experience the problem. That's the kind of use case where the analysis is so vital, the automated analysis.
Yeah, I would say the other interesting thing is, when I talk to people about AI and where we are in the journey of, do IT people trust AI now to drive their network? And I would say the interesting thing is, right, the same person who doesn't trust AI to drive their network, they will definitely get in that self-driving Waymo Uber. And so somehow they figured out how to trust that car to get them from A to B. So I think we're in that same journey of, how to get IT people to trust letting, some AI fancy software start to play with the data plane configuration.
I agree with that the underlying problem with this, I'll call it an epidemic, is complexity. Um, and people are afraid to touch their networks. I mean, the network engineers, the operators, they're stressed out. They're nervous before, during, after a change, whether it's provisioning a new service, a firmware upgrade, or whatever. It's stressful to them. And they're usually, we're drowning in data, but starved for insights. And it's that complexity that's really causing that epidemic of, just fear when people touch their network. So there's definitely an appetite to, right, as Bob's saying, start to hand over the reins to AI, something better to help rescue them.
Well, when you talk about handing it over the reins, Bob's example was great about this misconfigured router, right? Is that if we are still operating in the, and I hate to use this because it's such a trite analogy, but it's still applicable, the pets versus cattle analogy. If we are still in the world where we're hands-on to every device in our environment, when we get to thousands of devices, you will have somebody who misconfigures something. It's human nature. Mistakes happen. With AI, and we can go to intent-based management where we say, I want this thing to do this, and we let the AI, which is the expert, configure it appropriately. And then we can get away from the don't touch my network because it works now. And if I make a single change, the whole thing comes crashing down.
Well, I think it's a trust thing. As I'm saying, like when you get in that self-driving Uber, for some reason they trust it because they've heard enough stories about, hey, that self-driving Uber is actually safer than a human. I think that same process is going to happen in IT. We will eventually start getting these tools to the point where IT actually figures out that it's easier to trust that tool than it is a person who probably makes more mistakes than the tool does. Now, the interesting thing with these tools, they're undeterministic, because the other big paradigm shift is we're going from where we used to write scripts for API, where our enterprise customers are starting to write agent codes, right? MCP, they're starting to write this agent code, and they're starting to learn this kind of what a data center is on the other side, because the data centers were they're almost like a x86 on the front end and GPUs on the back end now. And as you start to use these Gen AI agents, you start to figure out the cost of how much it's going to cost per token to have my script automate something.
Yeah, the cost question is an interesting one, and we look at that, and I think I feel you're sort of tiptoeing along to the problem we see in the cloud of, well, the cloud is cheaper, so we move everything to the cloud, but then the cloud becomes more expensive because we're doing so much, and there was a non-predictability to an OpEx model versus a CapEx model. So people all of a sudden said, oh my God, I'm spending so much on the cloud, I have to pull that back in and repatriate it. And a lot of that is because they don't realize that the expense is going up because they're doing so much more than they could before, right?
To it, right? Once you start writing these Gen AI agents, you get addicted. You don't realize how many tokens you're actually using to solve a problem.
But yes, so the cost is gonna surprise people. You don't realize how much you're using it, but also is the ROI there? Are you getting the advantage back from doing it, automating it with AI versus paying an engineer to be the expert?
Yeah. And I think the other thing for those who watch it, right, the cost of a token is coming down because the data center guys are getting really good at optimizing these clusters now, right? In terms of how they train and even the inferencing of these big models. And so that's the other piece of the puzzle right now, what I call, AI for networking, networking for AI. Networking for AI teams are starting to get better at what they do.
And
Yeah.
in part, Bob, because of AI for networking, right?
Right. It's driving it, right? AI for networking is starting to drive the need for more networking for AI.
Yeah, I think the other thing that people don't sort of realize is that, I talk a lot in security about data security, and that data resides on a physical medium. It's a mechanical part, right? A spinning disk. And networking is all digital, except for there's a mechanical component to it, which are these cables that get plugged in and pulled out. And that's the root of how many problems would you say is a cabling problem where AI can somehow find that?
We have that. So right now, so we got models right now that basically find bad cables. And so when people actually get this stuff up and running, they start to see how many bad cables are in their network. They don't believe it until they actually start checking them. And they find out that model is probably 90% correct. They find out they've got these half duplex, half the pair is gone. It's not negotiating a gig anymore. It's negotiating 100 megs instead of a gig. So that is where they start to trust AI. I see that happening now, right? Once they get that feel for it, then they say, please don't ask me anymore. Just issue the ticket for that bad cable.
And that's like adopting any new technology. I mean, we start with just tell me the conclusion so I can judge your fitness. And we do this with junior engineers. We don't send a junior engineer to go and build a whole new infrastructure the first time. We watch them do it. In the same way with AI and any other technology, we look first for reports and tell me what you think is wrong. Tell me what you think is the remedial action. We often start by manually taking the same remedial action if we have any faith in it. But eventually we get sick of taking the same action. I certainly get sick very fast of taking the same action, and we'll hand it over to automation. So yeah, that trust has to be earned.
I thought you were going to say we send that junior engineer to go replace the cables.
Yeah.
Well, at the moment, we can't send an AI bot to go and replace the cables, but there's a whole mechatronic side to agents for the future.
Well, it's a funny thing. I'm sure you've tried ChatGPT. I would say ChatGPT is on par with probably a junior IT person. If you ask it to configure, give me the configuration for a Cisco router or Juniper router or something, it's tend to getting pretty good. I suspect that if you took a AI assistant and had to take the CCIE test, it may actually get pretty close to passing that thing.
Yeah, if it's well known, lots of prior art. If it's something that's well trained in, but that's your general knowledge junior engineer, actually an incredibly well trained junior engineer. It's probably somebody who has had a previous career and transitioned in with the amount of general knowledge that these large language models have. But it's the specialist knowledge over time that you're building into your products that's understanding how networks operate and where the dragons are in your network. And by the way, it's always DNS. It's never the network. It is very different using ChatGPT to give general purpose, general knowledge answers versus giving a fine-tuned, well-trained specialist knowledge large language models give you answers.
Yeah, I would say the interesting thing, the one thing I found, in addition to when I started Mist, I knew I had to go build this real-time cloud architecture to kind of solve this day two problem. The other thing I found is I had to really take my data science team and support team and tie them to the hip, because it turns out that the support team is the domain expert. Data sciences are great, but they really don't know the support problem. And that is where I found you really have to get that domain expertise tied in with the data science. And I think you'll see more organizations do that. Your support team is your domain experts. If they know more about what's going on in the networking than anyone else in your company usually.
Yeah, particularly the networking when it goes wrong.
When it goes wrong, right? I mean, they deal with the real problems. They know it better than the engineers know it, actually.
Well, one of the interesting things is, you think about ChatGPT, and there is, from a cybersecurity side, there is a security issue, of course, with exposing your data, a general enterprise data question to ChatGPT. I would think that we also wouldn't want to expose our entire network configuration to ChatGPT, which is why a specialist AI solution for AI for networking, right, is so important because it is going to give you the data protection, the security protections that you won't have if you just go out to a general purpose LLM.
I think most vendors, most vendors like ourselves, where if it's public documents, they're okay with sending that to Azure or OpenAI. But if we're talking about customer data or customer configs, that tends to have to stay in the VPC. That typically cannot leave the data center. You cannot let customer data outside of your.
Yeah, and I think you guys are hitting on a really important point. I mean, there's so many real AIOps examples in data center networking and other domains today that, around predictive maintenance, we got our AI assistants, service level expectations, application assurance. We have a ton of capabilities that are here and now, that have essentially been developed by the vendors like HPE, Juniper. But I think the most important area of AI ops, in the coming years is going to be just simple experimentation. I mean, these LLMs are these magical beasts that even the people who have designed them will even admit they don't understand always the intuition behind them. So it's important to just play, experiment. And a lot of that experimentation needs to come beyond the regular corporate product development roadmap process because A, it's too slow, and B, kind of what you guys are hitting on, there's some vendor liability issues. You know, do I want to put my name behind a customer bringing their own LLM and tying it into my enterprise application, my network automation and management tool? Probably not. But I do want that customer doing it because it's customer-led innovation. They're going to do some amazing, perhaps unexpected things. And we've seen time and time again in history, many industries, you put the tools in the hands of your customers and, they're going to lead a lot of the innovation. So I'm really looking forward to just what people in their garages are going to be doing outside of that formal corporate development, product development process.
I would I would say, Ben, I would agree, Ben. As I said, this agentic AI, this is a nonlinear, non-deterministic programming language. It's very iterative. It's totally different than the days of software engineering where I had a very deterministic. Tell me what you want, and I'll write you. It's taking. You don't know how long it's going to take to iterate yourself to a working solution, and it is non-deterministic, so it's not 100%.
So let's think about the non-determinism a little bit. So LLMs are non-deterministic, whereas the AI analysis engines and the other parts of AI are deterministic. But when you go to design an AI ops, how do you deal with the non-determinism in the tools that you're building and present that to customers? What do customers think about that?
Okay. I would say, it's like hiring your new employees. How often do your kids or some new employee does something, go, what the heck were they thinking? That's the point we're going to get to. The point is, these AI assistants aren't going to be perfect, but you're going to get to a point where they are more perfect than your human counterpart. The non-deterministic piece will be actually less happening than you would with an actual person. So I don't think you eliminate it all. I think you put guardrails around it and everything. You try to get to 99%. You want that AI assistant to be better than the actual human, the alternative.
And you do things like grounding the results and making sure that you are doing things like feeding the LLM up-to-date information about what is possible with the products that you've got deployed and what your policies are. And in that way, you can end up with an LLM that is better informed than your average human, because your average human is going to get bored reading that document and be thinking about what they're doing at the weekend when they should be studying closely. And so I think, yeah, Bob, you're right. Humans are not deterministic. I think that's one of the things that you got to remember. We aren't.
But you do want that deterministic, like that self-driving Waymo, right? That is it may make a mistake, but it's very deterministic from getting you A to B 99% of the time.
Well, I think that you go back to that example, and I think that's a very apt example. The determinism comes in we expect Waymo and Uber and the like on the self-driving cars to never have an accident. And, every time they have an accident, there's a big blast in the press, right? The car crashed or whatever, drove down. The last one I saw was it drove the wrong way down a construction road, right? So that's we can put that type of constraint and have that expectation because there's a human life at stake. When there's not a human life at stake, when it's just the network, does it have to be, and I don't think it does have to be 100% perfect. I think it has to just be better than as good as or better than what we have today.
I agree. And I think that's the same thing with the car, right? I mean, those cars are gonna, but you hope their accident rate is better than the human drivers.
So I did have a thought about that Waymo and the human driver is non-deterministic. If you've ever had a back and forth with your driver about where they're picking you up, somewhere downtown or at a hotel or at an airport, you can understand that there's non-determinism is acceptable in some places.
Right.
Whereas, as you say, that deterministic answer that if a pedestrian steps in front of my autonomous vehicle, the autonomous vehicle better stop. That there are places where deterministic is important. There are places where non-deterministic, as you say, slightly better than a human on average, is actually a really good outcome. And if we can continue to improve that, I think the concept of iteration in there is also vital, that getting a suboptimal result on the first iteration through is not so unusual, but as long as we can start improving the result on each iteration, and that those iterations maybe are even fully automated. So every 5 minutes we'll get closer and closer to the solution that we want. So long as we're tuning things well enough that every 5 minutes we're not oscillating off into something that is significantly worse. That non-deterministic behavior doesn't mean that we can't approach the correct solution.
No, I'm with you. But I got my first Waymo Uber. I did have that feeling. It's like I was okay getting in, and then I started thinking about it. It's like, where's it going to let me off? How's it going to figure this out?
But I think if you come back to sort of the networking side of the world, part of that iteration is having explainability, right? Is if the AI operations tool for networking, if it's a complete black box, it becomes a challenge for the early adopters, right? And they don't have an ability to say, to iterate and or provide correction, to say you're thinking you went down this path and you took a left turn here and you ran into a brick wall, for the car analogy, right, when you should have turned right instead of left. And so, ensuring that, I think we have to ensure that we have that explainability component. We can understand the chain of reasoning that an AI goes through as it's making its decision. Otherwise it becomes very hard for users to to really buy into the technology.
No, that's a given. Observability is key to trust. People need to see the evidence to earn their trust. You need to show your homework.
There's also the supply chain trust as well that has to be built out. As we're recording this, probably some time ago, as you're watching this, relatively recently, there was a news story about the Copilot AI that has been attacked. Basically, it's an open source plugin that goes into this. This was an open source plugin to go into Visual Studio Code, and a bad actor put some code into the public repo that would delete your entire cloud estate. And so governance of the supply chain for your AI is going to be absolutely vital to acceptance and trust in enterprise organizations.
Yeah, I think it's going to become like open source code. I mean, people are going to start looking at, where did you get the data to train it? Did you have the right to use it? You're right. There's going to be a lot more like software bombs. You want to know exactly, what's in what's in the components, what made that AI work. It's like the label on the back of your food. I want to know what's in that assistant.
Yeah, and it's mostly a good thing that I mean, I don't know about anyone else, but we're all buried in AI and the information and the speed at which it moves, and we want to be informed but not overwhelmed. But at the same time, everything, the information and tools seem so democratized. You can go to Hugging Face and download just about any AI model for free. The tools to prepare and organize your data for free. It's all there for people to use. But as you guys are pointing out, the flip side is, wow. I mean, talk about some attack surfaces being huge and major security issues with that. So it'll be interesting to balance those two things.
And again, that's where, we talked earlier on about, having some guardrails in place, and that's where guardrails are, and policy is very, very important there. There's got to be some policies that say, you can't just do a delete or a delete all, right? An RM minus RF all for all of us old timers, right? Without having something saying, are you really, really sure that you want to do this?
That's right. We'll hand it from one agent to another to do that. But before we get down that rabbit hole and spend a long time talking about governance, I think it's about time we brought a close to this episode. So thank you all for joining us today on the Tech Field Day podcast. But before we go, where can people connect with you, my guests, to continue this conversation?
I'm Jack Poller. You can find me on LinkedIn most often. That seems to be where all of the enterprise IT tech sessions are today.
Yep. And Bob Friday, Cloud AIOps, topic dear to my heart. Feel free to reach out on LinkedIn.
Ben Baker, HPE, Juniper also, and again, I'll throw my hat in the LinkedIn ring too.
And I'm Alastair, Cooke, an event lead here at Tech Field Day. So you can find me on LinkedIn, you can find me on all of the Tech Field Day estates, as well as you'll find lots of presence for us, for Jack as well, across on the TechStrong site. And Jack's been providing some awesome content across on TechStrong. So thank you for listening to this episode of the Tech Field Day podcast. If you enjoyed the discussion, please subscribe on YouTube or your favorite podcast application so you don't miss an episode. And do consider giving us a rating and a review, because that helps other people find this awesome content. This podcast was brought to you by Juniper Networks and Tech Field Day, home of IT experts from across the enterprise and part of the Futrim Group. For upcoming events and more episodes, head to techfieldday.com/podcast or view us on TechStrong TV. Thanks for listening, and we'll see you next week.